Question number 5 of exercise 13.3. The question is, a lab blood test is 99% effective in detecting certain disease when it is in fact present. Okay, so this means that in 99% of cases only a disease is detected correctly. Okay. However, the test also yields a positive result for 0.5% of the healthy person tested. Okay, so this means that if a healthy person is tested, then with a probability 0.005, the test will imply that he has the disease. Okay, so these are the cases for which a wrong positive result is given. Okay, now further we have been given if 0.1% of the population actually has the disease. What is the probability that the person has the disease given that his test is positive? Okay, so in this case we have to find the conditional probability that the person actually has the disease given that the test result is positive. Okay, so let us see how we are going to solve this question. So in this case we have to find the probability that the person has the disease given that the test result is positive. Okay, so for this we assume two events. E1 be the event that the person has the disease and E2 be the event that the person do not have the disease, and A be the event that the result is positive. Okay, and we have been given probability of E1 because only 1% of the population has the disease, therefore probability of any person having the disease will be equal to 0.1 upon 100, that is 0.001. Okay, probability of E2, because E1 and E2 are complementary event. Okay, therefore probability of E2 will be equal to 1 minus probability of E1. Okay, that is 1 minus 0.001 or 0.999. Okay, so this is the probability of E2 and we are required to calculate probability of E1 given A. Okay, now for this we are going to use Bayes theorem, and if we are going to apply Bayes theorem under this condition, it would be written like this: probability of E1 given A is equal to probability of E1 into probability of A given E1 whole upon probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Okay, and it should be noted here that probability of A given E1 would mean here that the result is positive given that the person has the disease, and probability of A given E2 would here means that the probability that the result is positive given that the person does not has the disease. Okay, so we are required to calculate these two probabilities to get the required answer. So probability of A given E1 would means that the probability that the test is positive given that the person has the disease, and this would be equal to 0.99 because in 99% of the cases the test is genuine, test is correct, so the test would be positive when the person has the disease, and it is going to be 99 upon 100 because 99% is given to us, and that is why its value is written as equal to 0.99. And probability of A given E2 would be the probability that the test is positive given that the person has no disease, and this value is provided to us for the wrong result, probability of the wrong result, that the test is positive when the person does not has the disease, and its value is given to us as 0.005. Now all we have to do, we have to place the values of probability of E1, probability of E2, probability of E1 given A is to be calculated. Applying Bayes theorem, we are going to get this result. So probability of E1 is written here, probability of E2 is written here. Okay, this is probability of E1, and probability of A given E1 is written here, and probability of A given E2 is written here. Okay, so on simplifying, this would give me 990 upon 990 plus 4995, and this would solve to give me 22 upon 133, which would be my required answer.
Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.